Hey everybody, this is Duke with an instructional video on how to build your FPV quadcopter in the UAS 2350 class. So I have this video as a reference for you guys to follow along and do some of the electronics in the build. So Ryan Rogers, who designed the frame that we're using, he has a video on how to build the actual frame and how to put the frame pieces together. And this video is meant to help you with electronics since that's not covered in his video, and we have specific electronics this semester we're using. So I'm going to try to be brief. I don't want the video to be too long, but give you pointers on all the different parts and components we're going to be adding this semester. So first I'm going to take this flight control actually off the frame. The first thing you want to note is when you're completing the construction of the frame, there are some different mounting holes. There we go. Try to show the different mounting holes here. So we have a number of holes in kind of a X orientation here that are meant for flight controllers or ESCs that are square and with kind of a flat front, if that makes sense. So if it were to be more like this, not this way. And then we have one set of screw holes that's a 25 by 25 millimeter direction. That's where the screws are actually installed in right now. And that's what we'll be using this semester. So when you assemble the frame with Ryan's video, make sure you install the screws into the 25 by 25 millimeter holes on the frame, not the other ones that are available. It'll be the only set that's basically set up in kind of a diagonal fashion so that the board sits in like a diamond shape rather than a square. Okay. And I realized in putting some of this together that the screws in the SpeedyBee kit, the ones that come with your flight controller, are not quite long enough for our entire build. So they'll fit the flight controller, but they won't fit our video transmitter. And that's okay. You can always grab some more screws from the lab that are a little bit longer while you're doing the build, but for general assembly, we're going to have to assemble this, do some soldering and stuff, and all of the measurements that we're taking on how long the wires need to be and such will be just fine. And then later when we take the quad apart to waterproof and coat the components, then we can put it back together with longer screws, and that shouldn't be a problem. So we also will use Loctite on the screws the second time around when we put it together. You don't need to use Loctite the first time around because you got to take it all apart anyways. So what we're going to do is I'm going to pause this video here for a second so you can jump over to Ryan's video and assemble the frame. So we have these screws assembled to then mount other components on so we can start doing some soldering. So go ahead and jump over to Ryan's video now and then come on back here and we'll finish up. Okay, so what we're going to do with this is going to run through the electronics that you'll need to install on the quad in order for it to function. I have kind of a demo build here. I'm not going to actually build the quad in this video. I need to use these parts for other students as well, so I can't solder them up and stuff right now. But I can show you kind of where things go and give you a little bit of an idea of what's going on with the build itself. I also encourage you to reference the instructions in the SpeedyBee kit, and which I'll show you in the video, as well as the instructions in your video transmitter bag as well. Okay, so here, let me zoom in a little bit. We have our quad frame, the bottom plate with these screws installed. Okay, got some nuts on those screws. It's very hard to see this kind of stuff with the camera, but it's on the screws, so the screws aren't going anywhere. They're just hand tight right now. That's all we really need to keep things stationary for soldering. We're going to take our flight controller all-in-one, flight controller ESC all-in-one board out of the box from the SpeedyBee box. We're going to install it on those screws like we would if we're doing our build, which would be in this fashion. This is the front of the aircraft towards the top of the screen. Okay, and you notice I have the capacitor installed already. The capacitor comes in the SpeedyBee kit. There's a little bag of accessories and stuff like that. It's in one of those, as is the XT30 pigtail that comes pre-assembled on one side. Okay, so we're going to talk about the power for the drone first, and then we'll go on to other components. I have here a 3D printed piece that's part of your kit. Yours may be a different color, but there's a piece that will look like this. Okay, and this is your XT30 holder. What it's designed to do here is thread your XT30 pigtail through and then install the connector into the plastic. Now I'm not going to push mine in all the way because I want to be able to get it back out easily, but it's meant to be seated all the way through there. This piece will then be later attached to your drone in the back here, and it will hold this connector for you, so you can just plug a battery in and then go fly. You don't have to try to zip tie the connector to something or keep it out of the way of the propellers. It's kind of contained right there, which I think is a really nice design. But we'll see at my capacitor here, it's a relatively large capacitor because this ESC is rated for 6S, up to a 6S battery. And so it's relatively big. We got to kind of keep it out of the way of the props. And so you'll see these pads in the back here. We have these large pads labeled positive and negative. Okay. And those pads are where the battery connects and where the capacitor needs to be mounted as well. So if we take the flight controller off, you'll see I've actually taken the capacitor, run it up through the bottom of the pads, okay, with some little insulation that comes with the capacitor to keep those insulated, and kind of bent it at a specific angle so that the capacitor comes back straight even though the board's at a 45-degree angle. Okay, we can't go straight out from the pads because, again, the capacitor will stick out way over here, and that will be too close to the motor and the propeller that's spinning. It'll be in the way. So you can mount the capacitor on the bottom like I did. You can put it on the top. However you want to do it, you really just need to get this mounted and insulated. So don't forget that heat shrink if you have a long part of the capacitor sticking out. And what I would then do is I would attach the capacitor with a little bit of solder to the pads, and then it's good to go. I just need to trim off the excess of the legs here. This silver part that's hanging off, that's extra. You'd trim that off, okay? And the capacitor would be attached. I can then take my battery lead and figure out how I want to route that. Let's move these motor wires out of the way. Maybe I want to come around and go around on the top or something, like so. Or maybe I want to come around this side and kind of lay it around the capacitor. I said you can do it a number of ways. You just want to make sure your power wires are attached in the positive and negative direction correctly. And of course, we don't have stuff out here on the arms by the props. You can also trim this. You don't have to use this length. You can trim this just like you trim the capacitor to length to fit our frame. So if you want it a little bit shorter, that's fine. Okay. But here we can see the capacitor. There is a side that is negative. You can see this marking as a negative sign. And also, it's hard to see once the legs are bent, but there's a shorter leg, and the shorter leg of the two legs is the negative leg. The longer one is the positive. So you can tell which way it is there. Don't solder it on backwards. It'll be a huge pain, and it will get damaged if you plug it in like that. Okay. But this is one way you could do it. You could put the capacitor on the bottom like that. It'll make it easy to put the capacitor down here and kind of zip tie it around this part of the frame so it's not moving and it's not getting anywhere it shouldn't, like into the prop. Okay. The props are very tight though, so don't let it hang out too far over here into this area here or onto the arm or anything. You might be able to bend the capacitor up a different way, but you do need to fit the capacitor and the power connectors both onto those pads. Okay. So whether you want to do it on bottom, top, whatever, however you want to mount that, you can of course fiddle around with a few different mounting methods. That's kind of why we do all this dry fit type stuff before we start soldering to make sure it's going to work and work how we want it to. You can install the capacitor on the top as well. I just wanted to show you that. Okay. And that can be done that way, and you kind of bend it back again the same way, or however you want to do that. Okay. So capacitor and power connector there. That should get you going on that. I'll take this out for the rest of the demonstration here so we can see a little bit better. All right. Next up are our motors. Okay, so you can see this motor's mounted here with one of these little yellow bumper skid pieces. I just have one screw in it to hold it in temporarily. Okay, when you get your motors, they'll come with a bunch of screws, like 5 bags of different sizes of screws. Okay, there'll be two sets of bags that are noticeably longer. We're not going to use those right now. And there are 3 sets of screws that are look similar in size, though they're not exactly the same. And these are actually different lengths. So if you sort them according to length, the screws we're going to end up using are going to be the ones that are the middle length. Okay, and the reason for that is because they're the right length to go up through the bumper, through the arm, and into the motor without going too far into the motor and damaging the copper coils, okay, on the bottom of the motor there, or damaging the wires that come from the motor. Okay, so remember there's 5 bags total of screws. Find the 3 ones that are smaller overall, and then sort those according to size. You use the middle size. Okay, I haven't actually measured those. I don't know how long they are, but you can measure them if you'd like. Too small, too big, just right. Okay, so use those. You'll use those on each motor, and you want to put at least a couple of screws in there probably to hold the motors in place while you start to do the next step, which is Let's zoom out a little bit. Measuring the motor wires. Okay, so each motor has 3 wires. Doesn't matter what order they're attached to the flight controller all-in-one board in. Okay, most people just do them straight across. They're not going to like twist them or anything like that. I just do them flat. Okay, so we'll take them flat across here, and we have 1, 2, 3 pads there, 1, 2, 3 here, 1, 2, 3 there, and 1, 2, 3 there. Those are for the motors. So bring them across. You're going to have to cut these down. They're too long to start with. You don't want them to be hanging off all over the place. They'll just get cut up by the propellers. We also don't want them to be taut or too tight. Okay, so give ourselves a little slack. We're going to want to zip tie these down to the arm probably. So you want a little bit of slack going up towards the flight controller all-in-one board. Maybe something like that would be a good length to then cut, tin the wires, and solder them onto your all-in-one board. And you throw a zip tie around here, and that'll hold the wires down. They have a little bit of slack here so they're not pulling and going to break and crash if they're too tight. Okay, so each motor will do that 4 times, of course, 1 for each motor. And that should get you your motors attached and cut to length. Okay. All right, next up we have a few of the items that are more on the flight controller side. The power that we did in the motor wiring is more on the ESC side. And now we're going to do some more on the flight controller side, even though it's all one board here. Okay. So I have here my instructions for my JEP RC RAD VTX, and then the flight controller as well. So these are really helpful to reference. We're looking at these a little bit in this video. Okay. So here we have the page with the flight controller, and we have a couple peripheral devices. 2 of these we're going to be installing ourselves. We have our receiver down here, and we have our video transmitter up here. Oh, and sorry, a camera. So 3 of these are all here. And so these help you understand where the wires should go on the flight controller to allow you to wire things up correctly. So if we take our receiver, this is an example receiver I have here. It's a little guy. This is the kind that I would recommend using if you haven't bought one yet. Buy one today. You'll need it soon. But it has a little tower antenna, so it fits really well in the small build. External antennas aren't really needed for these small builds. We don't fly them very far away, and you have plenty of range. So here's our little receiver. Okay, and on most receivers, it'll have some kind of silk screen, which is the lettering on the back. This is really hard to see. Let's see if we can zoom in a little bit by getting my hand closer. Where are we at? There we go. Okay, so you can kind of see there on the back, there's an R on the right hand side, there's a T, and then we have a, man, that is hard to see. You have a positive, oops, sorry, R and then T and then positive and negative, I believe, if I'm not mistaken. Make sure you check the pinout on yours. Okay, it could be different than that. They're not all the same order. We have a R, T, power, and ground. And so when we look at those 4 pads there, we look back at our flight controller diagram here, we see that our receiver, Express LRS receiver, which is what all of you are using, ground, power, T and R, TX and RX. And if we follow these along here over to the board, we can see power and ground go to power and ground. There's 2 pads here on the lower level. And then we have, they suggest T6 and R6, which are these pads up here on the upper level. Okay. And you see that the RX pad on the receiver goes to the TX pad on the flight controller. That's not a typo. RX goes to TX and TX goes to RX over here. So those kind of crisscross. Power and ground go straight across. Power to power, ground to ground. Okay. So in the terms of our physical build, zoom out a little bit here. Our physical build is going to be set up with the flight controller again like this. That's the front of the copter. Okay. And your receiver, you can physically, you can kind of tuck it back in here on the other side from the capacitor. You could probably tuck it in up here, one of these corners if you wanted to. We're going to have some space up there, so you could tuck it in right there or over here. Okay, our camera's going to be up in front, but we don't really have anything in like this frontal area because the motor wires will come in a little bit behind here on the back. So you could easily stick this right over here if you wanted to, or in the back. Wherever you decide to stick it, you're going to need to run the wires from the receiver to those pads we looked at in the diagram. Those pads are going to be located on this side or this corner edge of the flight controller. So power and ground, TX and RX. Okay. So you could do a little short wiring, just bloop bloop right there. You could run a little bit longer wiring and kind of go under and come back out over here and then get it back to the back if you want to put it on the back. Receivers are often mounted on the back of drones because usually you're flying away from yourself in a lot of scenarios. Okay, so we have better reception that way perhaps. You can mount it over here if you wanted to run it over to the other side for some reason. Those are all decent options, I think. And so you want to do the wiring that way for your receiver to all-in-one board wiring. If your receiver comes with wires, you can definitely use those. Okay, I got a little bit here. If you need more wire, then of course grab some out of the lab. Okay, we'll put that back. Next up after our receiver, we'll kind of go in order around this little diagram here. So we've done our receiver. We're not going to do a GPS this semester or LED strip. You can definitely add those on your own if you want. I'm happy to help you do that. But we are going to have a camera. This is the back of the camera right here. And so the camera, I don't have one that's open right now, so I'm just going to show you with the diagram. But we will take a look at that. This blue wire here is not one we use or really set up in class. You're welcome to check that out if you want to. It's just a camera control pad. But these three on the right-hand side are going to be used. We have power, ground, and video. Okay, a video signal. And it says ED and then the video. And these are on the other side of the board from where the receiver attaches over here. Okay, so it says E and D, and then our yellow is video, and those go over here to E and D, and the video comes in right there. Or sorry, cam. I guess it's the cam pad where the camera attaches right there. So that'll be relatively easy on our physical flight controller. Okay, our camera will be mounted up here in the front. Okay, and we'll have the three wires going back to our, let's see, I get this right, E, it's E and D, and then our cam pad is 1, 2, 3, 1, 2, 3 over here. That's the right one. So I have those three wires soldered to there. And on the camera side, you can kind of see here, there's actually a plug. So we just plug it on the camera side. So just make the wires long enough that you can install the camera and run the wires back from the camera to the all-in-one board. Okay. All right. Next up, and our last other peripheral device here is our video transmitter. Okay, so this is the JEP-RC RAD video transmitter. Here we have the pinout diagram for this. Okay. This can be used in a couple ways. We're going to use it one specific way in our build. So we can see here the device has two plugs. We're not going to use the smaller one at all, so don't worry about that at all. The larger plug comes with this harness in the package. And we're not going to use all the wires in that harness. We don't need all of those, so I've kind of folded a couple of them back here, the blue and the white. Okay. The reason for that is we just need these other four wires. Okay. We have power, ground, we have VTX, which is our video, and then we have IRC, which is our signal line. We don't need LED, we don't need cam. Okay. And what this is going to power the VTX with power and ground. And the VTX signal here is what's coming from the flight controller, which is the video from the camera now overlaid with our on-screen display. That's coming into the video transmitter and then getting broadcast out over the air. And our IRC line here is a signal line for the flight controller to send commands to the video transmitter to, for example, change channels, change power level, whatever you want to do. Okay. So the way we figured this out is if we look at this diagram, okay, let's kind of try to look them together here a little bit. This one on the right here is going to show us where these pads are for our video transmitter, even though this is a different one here. So we have power and ground, red and black, and then the green here is the signal line, IRC. That's going to go over here to this pad, T3, and then we have our video. It's going to go over to the VTX pad. So VTX, video, that's VTX here. Okay. We have our IRC, which is also labeled as IRC here, and that goes to our signal pad here. Okay. And then power and ground, they suggest A and B, which are some of these pads along the top. These are just 5-volt pads. There's actually a couple sets, so you can run them right over there to 5-volt ground here, or you could do 5-volt ground over here. As long as it's 5 volts, you'll be okay. And that helps us to connect our video transmitter to our flight controller in the correct way. Okay. Let's look at the physical layout here. Your video transmitter is going to mount on 3 of the 4 holes that your all-in-one board uses. So you can kind of mount it like this. You can mount it like this. I probably wouldn't put it over the USB port. I guess maybe you could. I don't know. We'll have to look at the spacing more once we actually build these out. But basically, you have this wire connection here you need. We'll get rid of these wires. We don't need these. And then you're going to need the antenna to plug into the video transmitter as well. The antenna is located here on the back. That's where the antenna plugs into anyways. So do not power the video transmitter up without an antenna installed ever. You'll damage the video transmitter. That's where the antenna is going to plug into, and then it needs to reach to the back of the drone because it will install in this little cavity here and run the cable down through here, kind of all one compact unit in the back. Okay? So we just want to make sure your antenna can reach. If it can only reach with it in this position, then you're kind of stuck in that position. If it can reach with it over here or maybe over here, then that would probably work as well. It probably won't reach with it here. It's not going to be long enough. Okay. But any of those will work. And then you want to trim these wires down to length. So if it reaches right here, we don't need to have all this wire hanging out. You want to trim it down so it's nice and compact. Give yourself a little bit of slack, maybe something like that, and solder it to those pads there. Okay. You don't want it so tight that you can't hardly take the thing apart for maintenance, but you don't want it so loose the wires are sticking out. So in between's good, maybe about right there. You kind of fold the wires down once you're done soldering, and that looks pretty good. All right. Okay. So that should explain. Oops, zoomed out a little bit too far. You see the messy desk. That should explain the wiring and setup of your drone. So for the completed construction assignment, what I'm looking for is that all those items are soldered on and attached, with appropriate wire lengths and not having a bunch of extra wire and stuff like that. Okay. And then you'll be able to, at that point, power it up with me. I'll help you power it up safely in a testing manner so we don't fry anything, hopefully. But I'll help you test it with the multimeter first. Then we'll power it up with a smoke stopper to make sure everything's good. If it all powers up and all is well, we can then start with the software configuration. Okay. All right. Let me know if you have any other questions, and hope this video helps. Thanks.